In this video I'm going to look at how to calculate the pH for weak monobasic acids. So we've got the generic formula here for a weak monobasic acid, HA. If you remember, monobasic just means the acid donates one proton. Now in the case of strong acids it was quite easy because if we knew the concentration of the acid, we automatically knew the concentration of H plus because of the complete dissociation in the strong acid. Now for weak acids we haven't got that because we've got partial dissociation. So if we know the concentration of the weak acid, we don't unfortunately know the H plus concentration. And remember, that's what we need to calculate the pH. So we need to adopt a slightly different method to the more straightforward one for strong acids. So to calculate the pH of this acid, we're going to actually employ the acid dissociation constant Ka. So there's the expression for HA. You can see I've simplified it slightly, and we can do this for monobasic acids because these two concentrations will always be the same because they exist in a 1-to-1 ratio. And remember, to calculate the pH of anything, we need to know the hydrogen ion concentration. So I've made that the subject of the equation. So the H plus concentration for our weak acid is the square root of the acid dissociation constant Ka multiplied by the concentration of the acid, HA. So I sometimes think of it like this: weak acid, pH, square root of Ka. Now there's a little approximation that takes place for this method, but it's okay to do this, it's acceptable. The HA concentration that we're actually going to input into the calculation to calculate the H plus concentration is the original concentration of the acid. In reality it's not, because this concentration here, which comes from here, which came from here, it's actually the concentration of the acid at equilibrium. I'll just quickly run through why it's okay to say that it's the original concentration of the acid. So you can see in red there I've put some extra information. So we'll say that the original concentration, or the starting concentration of the acid, the weak acid, is A moles per decimeter cubed. That means that initially we have no H plus and no A minus. Now let's suppose that X moles of HA dissociates. So at equilibrium we would have A minus X of acid actually left, and we'd have X moles of H plus and X A minus. Remember, they're always the same. Now the thing to appreciate is the amount that dissociates, X in this case, is absolutely tiny, and so therefore it's safe to say that the concentration at equilibrium, so whatever this is, it's really A minus X. It's okay to say that it's the original concentration, which would have been A. So there's two to try. 0.1 mole per decimeter cubed HA, Ka value given at 1 times 10 to the minus 4. Calculate the pH, and similarly 0.1 ethanoic acid has a Ka value of 1.7 times 10 to the minus 5. Calculate the pH. There's the first one. We get a pH when we minus log the H plus concentration of 2.5. And the second one comes out at a pH of 2.9.